I'm Rood, Professor Emeritus at the University of Michigan. As more and more are saying out loud that we cannot meet the 1.5 degree Paris climate goal, I thought some might find this short presentation useful. It is from a longer talk given at the National Science Foundation in April of 2022. The talk focuses on how to break down addressing climate change into long-term and short-term problems. It provides a framework for thinking about the global reduction of emissions by 2030 and why that is and always was ill-posed. A more important point, perhaps, is that there are many other ways to address climate change than the reduction of global emissions. These can be spread out on sensible timescales, which are far more rewarding than chronically falling short on global mitigation. Indeed, if we place global reduction of emissions on a practical timescale, then not only does that make the problem more manageable, but we can actually find progress has been made. That is covered in the original presentation, which is linked below. When faced with a complex problem, one strategy to gain some insight and understanding is to analyze the roles of space and time. One of the fundamental and challenging aspects of climate change is complexity of time. We are increasing our greenhouse gas emissions at an exponential rate. It takes time to realize the temperature effects of those emissions. If we were to successfully intervene, the benefits of that intervention are realized in the future. The temperature is rising. That increase is accelerating. And the effects of that temperature rise take time to be realized throughout the environment. If there is one thing COVID has taught us, as a collective, we do not deal well with challenges that have complex time evolution. For those who take on solving such a complex problem, understanding time is crucial. What is long-term and short-term? This axis shows time from now out to 100 years. Based on experience, I pose that timescales are best defined by human dimensions. On what timescales do we plan? When we build a power plant or a bridge, how long do we expect it to last? 50 years is a good span to separate long from short. Climate change has often been characterized as a long-term problem. However, there are many short-term issues that affect climate change. National security, energy security, and health security all influence our ability to address climate change. The economy is always of critical immediate importance. We want a good economy. Elections have large impacts on the willingness to address climate change. But is climate really a long-term problem? We've gotten to the point that each 30-year average of weather, climate is statistically different than the previous 30 years. Each 10-year average of weather, climate is statistically different than the previous 10 years. Each 10 years of accumulation of carbon dioxide adds heat whose effects will be realized for centuries. Development of plans, design, policy, and permitting, acquisition of funding, all of these essential parts of getting things done take years, often decades. There is, in fact, a short-term urgency of climate change. Aspects of climate change problem solving are present at all time scale. Evidence, our behavior, generally supports that these short-term crises impede our ability to address climate change. National security, energy security, and health security and threats to the economy usually motivate us to spring back to what we know how to do. And what we know how to do is burn fossil fuels. There are always crises, short-term imperatives. We need to expect them. We need to break the pattern of springing back to fossil fuels. We need to manage and sustain focus on climate change through these crises. What about space, spatial scales? We have challenges that are individual, local, regional, national, international, and global. We know that actions and events at one scale influence other scales. As we increase the spatial scales, We introduce more people, more jurisdictions, more agencies, more power holders, and more stakeholders. As we increase spatial scales, we incorporate more and more wealth holders. We also introduce more and more people without wealth. We incorporate more issues of inequity, social justice, and ethical values. A skill that I champion is to consider a problem in terms of time, space, and wealth. Long-term global problems intuitively are the most difficult to solve. Short-term local problems are intuitively easier. Wealth and ethical considerations increase the complexity in unpredictable ways because they rely on human choices, human values, and free will. Mitigation is global and long-term. The degree of difficulty is highest. The scale of adaptation can be local and near-term. Indeed, it can be individual and autonomous. Cost-benefit is clear and outcomes are measurable. There is benefit to identify local and near-term problems. They are more tractable. They play to measurable outcomes and successes. They are morale-boosting. Successes provide models that will scale up. They can have long-term and global impact. Now I want to think about one of our major messages. Headlines scream that we have until 2030 to reduce our emissions or we face catastrophe. As I was writing this talk, I saw the headline that we are firmly on track toward an unlivable world. We see one report, one headline after another, that we have an increasingly narrow path to meet the goal of limiting warming to 1.5 degrees. That path requires reductions of emissions to near zero by 2050. Along that path, we look to milestones that by 2020 we would see some reduction. We would be approaching 50% by 2030. Let's return to the results of the poll of my students. Some countries have made voluntary commitments to reduce their emissions by 50% by 2030. But 2/3 of my climate-smart students, who I imagine to be leaders in addressing climate change, do not see that reduction to 2030 goals happening in even 30 years. There's serious discord between the public discourse and what my students discern as truth. Let's consider this urgent message to reduce emissions by 2030 to avoid catastrophe. In this graph, the horizontal axis is time. It is split. On the left, time is measured in years. On the right, time is measured in decades. The vertical axis represents emissions. The line shows our history of increasing emissions. This curve represents an intervention that takes us off of our historical path towards a goal such as 1.5 or 2 degree rise in average surface air temperature. The next curve shows that if we wait just a small number of years, then we have to turn off the emissions faster. Likewise, the third curve. We eventually get to a point of the fashionable thought experiment of having to turn off our emissions immediately to be able to meet the temperature targets. We are already very close to that point. I am a senior citizen, and I expect to see the 1.5 degree threshold in my lifetime. If we pose we have until 2030 or all is lost, then we take the hardest global problem, mitigation, and place it on the shortest time scale, which is effectively a singularity. Problem solving breaks down. The ability of people to gain agency over the problems of climate change appears impossible. We will not reduce emissions by 50% by 2030. In 2031 will not only be habitable, but it will have some pretty nice weather. This will cause us climate scientists grief.